Okay, in this video, I want to talk about how we can make unit conversions using T-charts. We started to do a little bit of unit conversions at the end of last week, and now I'd like to show you a new technique that utilizes the unit conversions from last week. So you'll definitely want to have this this set of conversions available to you, either on the computer or if you've printed out a copy. And we'll work through several of them today in this video. The first few are what I would call one-step conversions. So you could use the T-chart method that I'm going to show today, or you could not. The T-chart method really comes into play when you get into these multiple step problems, and you'll see why in just a few moments. All right, question number one, single step method. A certain runway needs to be 3 miles long in order to handle an extremely large aircraft. The length of the runway must be measured in feet to estimate the cost to paint the markings. So in that situation, our goal is to convert 3 miles into feet. Now, what's particularly nice about this T-chart method is that it helps eliminate the guesswork when it comes into our unit conversions, especially with standard units, when we're guessing or when we're deciding to multiply or divide. And I'll show you what I mean here. What I'm going to do is I'm going to start by writing what we know. We know that we've got a runway that's 3 miles long, and I'm going to draw a T around that. And this T actually represents a series of fractions that are next to it. So I'm going to write this as 3 miles over 1. Just like any number, the number 3 could be written as 3 over 1. I'm going to write this as 3 miles over 1. Now, in a minute, I'd like to convert miles into feet. And the way these T-charts work is that if I've got a unit in the top of a T-chart, along this top row here, and I again get that unit in the bottom of that T-chart, then these two units are going to cancel in our T-chart process. And so in the denominator, I'm going to write the word miles because I would like to cancel these units. I'd like to convert away from miles and into feet. And so I'm going to ask myself, is there a conversion factor that deals with feet and miles? And if you don't know this off the top of your head, you can go back to your common unit conversion sheet. And let's see here. I think this is one that we added in the video of last week. Yeah, in these common conversions, we went ahead and added this. 1 mile is 5,280 feet. Well, this is the conversion that I want because it has both miles and feet in it. That's the conversion factor that contains miles and feet. And so with that, I'm going to come back to the assignment here, and I'm going to say that there's 1 mile and 5,280 feet. That's what our conversion factor was telling us. For 1 mile, there is 5,280 feet. And so now that I've got my T-chart built, I'll go ahead and go through the math process here. And the process is this. We multiply across the rows, and we produce a new fraction at the very end. So across the top here, I'm going to multiply 3 times 5,280. So I'll use a basic calculator for that. 3 times 5,280 is 15,840. And I'm going to use the unit feet here because, well, that's the unit that's left over. This unit, miles, got canceled out. So we're left with feet across the top. Across the bottom, I've got the number 1 times 1, which is 1. And my unit got canceled out, so I don't have to report that here. So my end result would be this fraction, or if I'd like to eliminate the fraction, I could always take the numerator, divide by the denominator, which is easy in this case. 15,840 divided by 1 is 15,840. And we now know that this runway that was 3 miles long is exactly the same as 15,840. Now, of course, that's the long way, especially if you remember that our conversion rule said that if we take a big unit, like miles, and convert to a small unit, all we have to do is simply multiply by the conversion factor. So 3 times 50 to 80 would have gotten us the result in one step, which, again, I agree, but let's establish this technique first and you'll see how it pays off in the long run. In example number 2, a bag of concrete is measured in pounds, but our plans require the weight of the concrete to be measured in kilograms. So let's convert 120 pounds into kilograms. So again, I'm going to start with what I know, which is 120 pounds, and draw a T-chart around that. I'm going to write that as 120 pounds over 1, and I'd like to get pounds to cancel. And what I would really like to see is if there's a unit conversion that takes kilograms and pounds and relates them to one another. So I'm going to jump back to my sheet over here, and I'm looking for kilograms and pounds together in the same conversion factor. And I don't see it here in this section, so I'll keep looking down below. Here we go. Here's one. 1 pound to 0.454 kilograms. That's good. Or you could use this one, 1 kilogram to 2.2 pounds. The nice thing about the T-chart method is that it doesn't matter. You can use either or as long as you list your number in the correct spot. So let's start with this one at the top for a second here. We've got 1 pound is the same as 0.454 kilograms. So I'm going to put 1 pound, 0.454 kilograms. That's what our conversion factor said. Now with these T-charts, the math requires us to multiply the top row together. So 120 times 0.454 is 54.48, and I should have noted that pounds canceled with pounds and we're left with kilograms in the numerator. And across the denominator, well, 1 times 1, that's easy, is 1, and there is no unit down there, so we'll call this 54.48 kilograms. And units are really important in this assignment, so let's make sure that we use them. Now, if I use the other conversion factor, well, let's see how that would turn out. 120 pounds over 1. Build that T-chart here. Pounds and kilograms. We still write the T-chart in this order because we want pounds to cancel with pounds. Make a distinction here. We're doing a separate problem now. Pounds are going to cancel with pounds, and kilograms are the units that we're hoping to have left over. But if I go back to that conversion chart for a second and use this number instead, 1 kilogram and 2.2 pounds, well, that means we'll write 1 kilogram here and 2.2 pounds here. And now when we multiply straight across, I have 120 times 1, which is 120 kilograms. That's the unit that's left over. And across the bottom, I have 1 times 2.2, which is 2.2 here. And again, no units. In this case, I do need to divide this fraction to simplify. It's not quite as easy as before. So I'll take the number 120, divide by 2.2, and now I've got, well, look at that, 54.545, 54.545 kilograms. And the two results are the same. Well, close enough. There apparently was some rounding differences that we encountered here and here, but in this particular assignment, I'm not going to be that critical. As long as I see that you're close and your process was correct, then I'm happy with that. Okay, I'm going to leave 3, 4, and 5 for you to complete, and you can reference my solutions that I have posted online, but do give them your own thought first before referencing the solutions that you can find out there. Also, do keep in mind that I don't want you to use smartphones or Google or any other computers with conversion factors on this. Use the T-chart method only. I'll pick up in another video to talk about the multi-step problems.